Axiomatic Product Development Lifecycle, APDL, also known as Transdisciplinary System Development Lifecycle, TSDL, and Transdisciplinary Product Development Lifecycle, TPDL, is a systems engineering product development model proposed by Bullet Gunless that extends the axiomatic design AD method. APDL covers the whole product lifecycle, including early factors that affect the entire cycle, such as development testing, input constraints, and system components. APDL provides an iterative and incremental way for a team of transdisciplinary members to approach holistic product development, a practical outcome including capturing and managing product design knowledge. The APDL model addresses some weak patterns experienced in previous development models regarding quality of the design, requirement management, change management, project management, and communication between stakeholders. Practicing APDL may reduce development time and project costs. APDL adds the test domain and 4 new characteristics to axiomatic design AD. Input constraints in the functional domain, systems components in the physical domain, process variables tied to system components instead of design parameters, and customer needs mapped to functional requirements and input constraints. APDL proposes a V-shaped process to develop the design parameters and system components. Detailed design. Start top-down with process variables, PV, and component test cases to complete the PV, CTC, and functional test cases, FTC. And after build, test the product with a bottom-up approach. APDL domains. Customer domain. Customer needs are elements that the customer seeks in a product or system. Functional domain. Functional requirements completely characterize the minimum performance to be met by the design solution, product, etc. FR documented in Requirement Specifications, RS. Input constraints are included in functional domain along with the FR. IC are specific to overall design goals and are imposed externally by CN. Product users or conditions of use, such as variations, IC are derived from CN and then revised based on other constraints that the product has to comply with, but not mentioned in the customer domain. Physical domain. The design parameters are the elements of a design solution in the physical domain that are chosen to satisfy their specific FRs. DPs can be conceptual design solutions, subsystems, components, or component attributes. System components, SC, provide a categorical design solution in the DP where the categories represent physical parts in the physical domain. The SC hierarchical represents the physical system architecture of product tree. The method of categorizing varies. Eppinger portrays general categories as system, subsystem, and component Eppinger, 2001. NASA uses system, segment, element, subsystem, assembly, subassembly, and part, NASA 1995.